Hello guys, and welcome back to this channel. In today's video, we want to discuss 3 set problems. We are going to solve a number of examples on this topic. So let's solve our first example. Mathematics, English and life skill books were distributed to 50 students in a class. 22 had mathematics books, 21 English books, and 25 life skill books. 7 had mathematics and English books, 6 mathematics and life skill books, and 9 English and life skill books. Find the number of students who had A, all the 3 books, B, exactly 2 of the books, and C, only life skill books. So to solve this problem, let's write down some information we derived from the problem. From the question, 3 types of books were distributed to 50 students. So the number of students in our universal set is 50. 22 had mathematics books. So the number of students who had mathematics books is 22. 21 English books. 25 life skill books. Now we are also told that 7 had mathematics and English books. So that is mathematics intersection English is 7. Now the number of students who had mathematics and life skill books is 6. Mathematics and life skill books is 6. And then 9 students had English and life skill books. So English and life skill, 9 students. Now let the number of students who had all the 3 books be X. So mathematics intersection English intersection life skill is X. Now let's represent this information on a Venn diagram. Afterwards, we are going to solve for A, B, and C. So the number of students in our universal set is 50. Because we are talking about 3 types of books, we are going to draw 3 circles. The number of students who had mathematics books is 22. The number of students who had English books is 21. And the number of students who had life skill books is 25. Now we said that the number of students who had all the 3 books is X. And the number of students who had mathematics and English books was 7. So that is going to be 7 minus X. The number of students who had mathematics and life skill books was 6. So we have 6 minus X. And the number of students who had English and life skill books was 9. So we have 9 minus X. So 7 minus X represents the number of students who had mathematics and English books only. 6 minus X represents the number of students who had mathematics and life skill books only. And then 9 minus X represents the number of students who had English and life skill books only. Now let's derive an expression for the number of students who had mathematics books only, English books only, and then life skill books only. So let's start with mathematics books. Now the number of students who had mathematics is 22. So we are going to consider this circle for mathematics books. The number of students who had mathematics books is 22. So if you want to find the number of students who had mathematics books only, we are going to subtract 7 minus x plus 6 minus x from 22. So we have 22 minus 7 minus x plus 6 minus x. Now 7 plus 6 is 13. Negative x cancels out positive x, and we are left with negative x. So we have 22 minus 13 plus x. 22 minus 13 is 9. So we have 9 plus x. So this is the expression for the number of students who had mathematics books only. So let's write 9 plus x here. Now let's solve for the number of students who had English books only. So for English books only, we have 21 minus, we are going to consider this region, this circle. So we have 7 minus x plus 9 minus x. So we have 21 minus, now 7 plus 9 is 16. So 16, negative x cancels positive x, we are left with negative x. So we have 21 minus 16 plus x, which is, now 21 minus 16 is 5. So we have 5 plus x. So this is the expression for the number of students who had only English books. Now for the number of students who had only life skill books, that's going to be 25 minus, we are going to consider this circle, 6 minus x plus 9 minus x. So we have 25 minus, now 6 plus 9 is 15. So 15, negative x cancels positive x, we are left with negative x. Now 25 minus 15, 25 minus 15 is 10. So we have 10 plus x. So the number of students who had only life skill books is 10 plus x. So we've been able to complete our Venn diagram. Now let's consider the universal set. So the number of students in the universal set is 50. So we have 50 equals, now the universal set is made up of all the values or expressions in the circles. So 50 equals, let's start from mathematics. We have 9 plus x plus 7 minus x plus 6 minus x plus 5 plus x plus 9 minus x plus 10 plus x. So the universal set is made up of everything inside the circle. Now let's solve for x. 9 plus 7 is 16, plus 6 is 22, plus 5 is 27, plus 9 is 36, plus 10 is 46. Now x cancels out negative x, positive x cancels out negative x, positive x cancels out negative x, and we are left with positive x, so plus x. Now we can transpose 46 to the left hand side. So we have 50 minus 46 equals x, and then x is 4. So the number of students who had all the 3 books is 4. So we've been able to answer the A part. Now let's solve for B. That is the number of students who had exactly 2 books. Now to find the number of students who had exactly 2 books, we are going to add expressions in this region, and this region. So that is 7 minus x plus 6 minus x plus 9 minus x. Now x is equal to 4. So we have 7 minus 4 plus 6 minus 4 plus 9 minus 4. 7 minus 4 is 3. 6 minus 4 is 2. 9 minus 4 is 5. So 3 plus 2 is 5. 5 plus 5 is 10. So the number of students who had exactly 2 books is 10. So number of students who had exactly 2 books is 10. Now let's solve for C, the number of students who had only life skill books. So for only life skill books, we are going to use this expression. Now we know that x is equal to 4. So 10 plus x becomes 10 plus 4, which is 14. So the number of students who had life skill books only is 14. So this was a very simple problem. Now let's move on to solve the second question for today's video. So for the second question, there are 30 students in a class. 20 of them play football, 16 play hockey, and 16 play volley. 9 play all the 3 games. 15 play football and volley. 11 play football and hockey, while 10 play hockey and volley. A. Illustrate this information or the information on a Venn diagram. B. Using the Venn diagram, find the number of students who play at least 2 games. And C. What is the probability that a student chosen at random from the class does not play any of the 3 games? So let's write down the information we gather from the question. So we have the universal set containing 30 students. So the number of students in the universal set is 30. 20 of them play football. So the number of students who play football is 20. The number of students who play hockey is 16. And the number of students who play volley is also 16. Now we are told that 9 play all the 3 games. So football intersection hockey intersection volley is equal to 9. 15 play football and volley. So football and volley, we have 15 students. And then 11 play football and hockey. Football and hockey, 11 students. And then 10 play hockey and volley. So hockey and volley, we have 10 students. So let's represent this information on the Venn diagram. So we have the number of students in the universal set to be 30. The number of students who play football is 20. Number of students who play hockey is 16. And the number of students who play volley is also 16. We are told that the number of students who play all the 3 games is 9. So we have 9 here, and the number of students who play football and volley is 15. So if you want to find the number of students who play football and volley only, we are going to subtract 9 from 15. So 15 minus 9 is 6. So we have 6 here. The number of students who play football and hockey is 11. So if you want to find the number of students who play football and hockey only, it is 11 minus 9, which is 2. And also the number of students who play hockey and volley is 10. So the number of students who play hockey and volley only is 10 minus 9, which is 1. Now let's find the number of students who play football only, hockey only, and volley only. So let's start with football only. So for football only, we are going to consider this circle. Now the number of students who play football is 20. So we have 20 minus 2 plus 9 plus 6. Now 2 plus 9 is 11. 11 plus 6 is 17. So we have 20 minus 17, which is 3. So the number of students who play football only is 3. Now let's find the number of students who play hockey only. So for hockey only, we are going to consider this circle. So 16 students play hockey. So we have 16 minus 2 plus 9 plus 1. Now 2 plus 9 is 11. 11 plus 1 is 12. 16 minus 12 is 4. So we have 4 students who play hockey only. Now for volley only, the number of students who play volley is 16. So 16 minus, let's consider this circle. So we have 6 plus 9 plus 1. 6 plus 1 is 7. 7 plus 9 is 16. So 16 minus 16 is 0. So it means that we have no students playing volley only. So we've been able to complete our Venn diagram. So hockey only we have 4, volley only we have 0. Now let's solve for B. The number of students who play at least 2 games. So at least 2 games means that we need to find the number of students who play 2 or more games. It shouldn't be less than 2. Now for exactly 2 games, we have 2 plus 6 plus 1. So 2 plus 6 plus 1. And then all the 3 games is 9. Because we are looking for at least 2 games, it's supposed to be 2 or more games, not less than 2. So we have this group of people playing exactly 2 games, and then we have this group of people playing all the 3 games. Now 1 plus 9 is 10, 10 plus 6 is 16, 16 plus 2 is 18. So the number of students who play at least 2 games is 18. Now for C, what is the probability that a student chosen at random from the class does not play any of the 3 games? So first of all, let's find the number of students who do not play any of the 3 games. So to find that number, we are going to add up all the numbers in the circles and then we subtract from the universal set. So the number of students who do not play any of the 3 games is equal to 30 minus, now we have 3 plus 2 plus 9 plus 6 plus 4 plus 1 plus 0. So 3 plus 2 is 5, 5 plus 9 is 14, 14 plus 6 is 20, 20 plus 4 is 24, and then 24 plus 1 is 25. So this is the number of students who do not play any of the 3 games. Now let's find the probability that a student chosen at random does not play any of the 3 games. So the probability that a student chosen at random does not play any of the 3 games is going to be 5 divided by the number of members in the universal set, that is 30. So 5 goes into itself once, into 30 6 times. So the probability that a student chosen at random from the class does not play any of the 3 games is 1/6. Now let's solve the third question. So for the third question, there are 22 players in a football team. 9 play defense, 10 play midfield, and 11 play attack. 5 play defense only, 4 play midfield only, and 6 play attack only. A. Represent this information on a Venn diagram. B. How many play all the 3 positions? So let's write down the information we gather from the question. There are 22 players in a football team. So the number of members in the universal set is 22. We are told that 9 play defense. So the number of players who play defense is 9. 10 play midfield. And 11 play attack. Now we are also told that 5 play defense only. So the number of players who play defense only is 5. The number of players who play midfield only is 4. And the number of players who play attack only is 6. Now let the players who play all the 3 positions be X. So we have defense intersection, midfield intersection, attack, that is X. Now let's represent this information on a Venn diagram. So the number of members in the universal set is 22. We are going to have 3 circles. The number of players who play defense is 9. The number of players who play midfield is 10. And the number of players who play attack is 11. And then also the number of players who play all the 3 positions is X. Now the number of players who play defense only is 5, midfield only 4, and attack only is 6. So defense only is 5, midfield only is 4, attack only is 6. Now let the number of players who play defense and midfield only be A minus X. Let the number of players who play defense and attack only be B minus X. And the number of players who play midfield and attack only be C minus X. Now let's consider each of the 3 positions. Let's start with defense. Now the number of players who play defense is 9. So we have 9 equals, considering this circle, we are going to add up all the contents of this circle. So that is 5 plus a minus x plus x plus b minus x. Now negative x cancels out positive x. So we are left with 5 plus a plus b minus x. Now let's transpose 5 and negative x to the left hand side. So we have 9 minus 5 plus x equals a plus b. So a plus b is equal to 9 minus 5 is 4. So 4 plus x. Let's call this equation 1. Now for midfield, the number of players who play midfield is 10. So we have 10 equals everything in this circle. So we have 4 plus a minus x plus x plus c minus x. Now 10 minus 4 is 6. So we have 6 equals a, negative x cancels out x. We are left with a plus c minus x. Now let's transpose negative x to the left hand side. So we have 6 plus x equals a plus c. Let's call this equation 2. Now let's consider attack. So for attack, we have 11 players playing that position. So 11 equals b minus x plus x plus c minus x plus 6. Negative x cancels out positive x, so that we are left with 11 equals b plus c minus x plus 6. Now let's transpose negative x and then 6 to the left hand side. So that is 11 minus 6 plus x equals b plus c. Now 11 minus 6 is 5. So 5 plus x is equal to b plus c. Let's call this equation 3. Now from equation 1, let's make a the subject. So from equation 1, a is equal to 4 plus x minus b. Let's call this equation 4. Now let's consider the universal set. So members in the universal set sum up to 22. So we have 22 equals everything within the circles. So that is 5 plus 4 plus 6 plus a minus x plus b minus x plus c minus x plus x. 5 plus 6 is 11. 11 plus 4 is 15. Negative x cancels out positive x. So we are left with a plus b plus c, and then negative x minus x is negative 2x. Now let's transpose 15 and negative 2x to the left hand side. Now 22 minus 15 is 7, and then negative 2x becomes plus 2x equals a plus b plus c. Let's call this equation 5. Now from equation 3, b plus c is equal to 5 plus x. So let's put equation 3 into equation 5. So 7 plus 2x equals a plus, now in place of b plus c, we are going to substitute 5 plus x. So that is 5 plus x. Now let's transpose 5 plus x to the left hand side. So that is 7 plus 2x minus 5 minus x equals a. Now a is equal to 7 minus 5 is 2, and then 2x minus x is x. So we have a equals 2 plus x. Let's call this equation 6. Now from equation 6, we have a to be 2 plus x, and then for equation 4, we have a to be 4 plus x minus b. So let's equate the two equations. So a is equal to a. We have 4 plus x minus b equals 2 plus x. Now let's transpose 2 plus x to the left hand side and then negative b to the right hand side. So it becomes 4 plus x minus 2 minus x is equal to b. Now b is equal to 4 minus 2 is 2, x minus x is 0. So we have b to be 2. Now let's put b equals 2 into equation 5. This is equation 5. So that is 7 plus 2x equals a plus 2 plus c. Now let's transpose 2 to the left hand side. So it becomes 7 minus 2 plus 2x equals a plus c. So we have a plus c to be 5 plus 2x. Let's call this equation 7. So for equation 7, we have a plus c equals 5 plus 2x, and then for equation 2, we have a plus c equals 6 plus x. So we can equate the two equations. So equation 7 equals equation 2. So we have 5 plus 2x equals 6 plus x. Now let's transpose x to the left hand side and then 5 to the right hand side. So that is 2x minus x equals 6 minus 5. Now 2x minus x is x, 6 minus 5 is 1. So we have the value of x to be 1. So the number of players who play all the three positions is 1. Now considering the Venn diagram, we've been able to find the value for b, we've been able to find the value for x. Now let's find the value for c and a. So from equation 4, we have a equals 4 plus x minus b. So a equals 4 plus x. Now x is 1. So we have 1 minus b is 2. So minus 2. Now 4 plus 1 is 5. And then 5 minus 2 is 3. So we have the value of a to be 3. From equation 2, we have a plus c equals 6 plus x. So from equation 2, we can transpose a to the left hand side. So that becomes 6 plus x minus a equals c. So c is equal to 6 plus x is 1 minus a is 3. So we have c equals 6 plus 1 is 7, 7 minus 3 is 4. So the value of c is 4. Now let's represent all this information on the Venn diagram. So after solving for the unknowns, we had the values of a to be 3, b to be 2, c to be 4, and then x to be 1. Now let's redraw the Venn diagram. So number of players who play defense is 9. Number of players who play midfield is 10. Number of players who play attack is 11. The number of players who play defense only is 5. The number of midfielders only is 4. And the number of attack only is 6. X is equal to 1, which is the number of players who play all the 3 positions. That is 1. So the number of players who play defense and midfield only. So defense and midfield only was A minus X. Defense and attack only was B minus X. Midfield and attack only was C minus X. Now we have A to be 3 and then X to be 1. So the number of players who play defense and midfield only will be 2. The number of players who play defense and attack only is B minus X. B is 2, X is 1, so we have 1. So defense and attack only is 1. And then midfield and attack only is C minus X. C is 4, X is 1, we have 3. So midfield and attack only is 3. So that is for A. Now B, the number of players who play all the 3 positions is 1. So we have only 1 player who play all the 3 positions. So that's it for today's video. Thanks for watching. See you in my next video. Do well to subscribe, like and share this video to your friends. Bye bye.